So we've done all that work. It's taken a while, but now we're ready to draw the actual graph of our function. All of those things that we've done are just the pieces that help us get the shape, and everything that we just did is what I expect you to be able to do by hand for any of the examples that we'll have. Now, if you have a graphing calculator, you can certainly use that to help with this next part and make sure that you have the right pieces going through the right places, or just make sure that you've found the different parts right. But what I don't want to see is just a drawing of the graph and nothing else when you're graphing these. I want to see the work you do to find the asymptotes, the work you did to find the x-intercepts, and I want to see the equation for your horizontal asymptote. All of those things you should be able to do by hand, but I definitely want you to take advantage of your graphing calculator and the capabilities that it has to do these graphs. Now, if you don't have a graphing calculator, don't worry. You can do all these by hand. It just takes a little bit more thinking, and we'll try to get that worked out on our examples. So let's look at those. Y equals 1 over x. We've got our vertical asymptote. We have no x-intercepts. We have our horizontal asymptote of y equals 0. So we're pretty sure that this graph either goes, it's along the asymptotes like that in some of those sections. So how do we know which ones it goes in? I think the easiest thing to do is check the signs if we plug things in. So if we plug in values over here, we would be plugging in positive x values. And if we plug in positive values, what are we going to get? 1 over a positive number is positive. So our graph is going to be on the positive side of those asymptotes. And we just use those asymptotes as a guide to draw that graph. It's never going to hit x equals 0. It's going to get closer and closer to y equals 0 as we go further out. And then I'm not too concerned about things that happen between there. Okay, just use those asymptotes as a guide. Now, if you draw something like this, right, then we have a little bit of a problem. It should just be a smooth, nice, and pretty simple curve. Okay. So what about on the other side? If we're plugging in negative x values, so if we plug in negatives, 1 over a negative is going to spit out negatives, so we're going to be down here. Okay. And if you were to have graphed 1 over x on your graphing calculator, you would see that and you'd have those pieces fine. But I still just want to see all of this work on your paper. So we'll use this same trick with signs going forward. Looking out to the right, if we plug in positives, plugging positive for x will be positive. Plugging in positives and x squared is positive. So as we plug out large positive values, we're positive. So we're probably above in that top section on that side. Going out to the left, we would be plugging in negatives that whole time. So if we plug in negatives, the top would give us a negative. On the bottom, negative squared is positive. So we'd have negative over positive, which gives us negative. So we're probably down below in that bottom section. Now what happens in the middle can be kind of tricky. A lot of different things can happen. Our graph might come down and go back up. It might go up and go back down. It might come all the way down and hit our x-intercept, or maybe up from the bottom and hit it there. Maybe it comes down, goes through it, and keeps going down. Maybe it comes up, goes through, and keeps going up. And you probably might be thinking, well, how the heck do I know which one of those it does? Part of it is just takes time. The more of these that you graph, the more of the possibilities that you'll see and can make some better judgments. Or we can kind of work through it the way we did on the outsides of the graph. Let's just do this. Let's plug in -1 and 1 and see what happens. If we plug in -1, that's negative on top. If we plug in -1 down here, that'd be a 1 minus 4, which gives us negative. So plugging in -1 gives us negative over negative, which is positive. So at -1, our graph is positive. If we plug in 1, we would have positive over 1 squared is 1 minus 4 is negative. So we would have a positive over a negative, which would give us a negative value, so our graph is down there. So what's going to happen on this one, it's going to come down that asymptote, curve through our x-intercept, and then keep going down as we get closer to that vertical asymptote. This next one is tricky, deciding where things go out here, because our asymptote isn't at 0. So whether we're above it and really close to it or below it and really close, either way we should be getting negative values. So if we try that test where we plug in positive values, the top is going to give us negatives and the bottom gives us positives, and so that's negative over positive, which is negative. Well, either way, as we go out towards these large values, it's negative. So you could try plugging in some points, but you really need to plug in something very close to 2, so just barely more than 2, to decide whether you're up here or down there. So the other better options are using your graphing calculator to figure out whether it's above or below. Or if you don't have one of those, just make a guess. If you draw something that makes sense with the asymptotes that you have, I'm not going to mark you down for that, okay? But if you graph this on your graphing calculator, it is below on this side, it's below on the other side, and then maybe you can guess that with our horizontal asymptote, we maybe don't want to go through there, but we do have this x-intercept up here, that this is one that comes down here, goes through that x-intercept, and back up. Okay? If you're not sure how to graph this on your graphing calculator, we will look at that in the next videos, and there's even like a worksheet, and I'm going to kind of make a tutorial for how to do these things on your graphing calculator. Last one, and the least favorite of all the cases, the one where we have the slant asymptote. Again, best option, probably just use your graphing calculator. Maybe so I guess let's look at this. Let's do the positives, negatives thing. So if we plug in positives, this is going to give us positives, right? If we plug in negatives, we're going to get out positive over negative, so negatives. So from this side of our asymptote, it's going to curve and have to go back along that asymptote. And from down here, it's going to have to curve back along that asymptote. Now what makes this one kind of tricky is the x-intercepts, because it would make sense or seem nice if our graph just came up and inside those asymptotes and went back along with it. But that can't be the case, because we know we have to hit these two x-intercepts. So what probably happens instead is we get this one on the left coming up through there and coming back down with our asymptote, and then the one on the right, maybe something similar, maybe not quite as far, maybe that one sticks inside. Use a graphing calculator to help, or draw something that makes sense. You should definitely hit both of the x-intercepts and go along the what am I trying to say? The asymptotes. Okay? If you draw something that comes down this way and goes through there, you hit both x-intercepts, but then this piece is not going with your asymptote. Okay? So something's off there. So just do your best to try and hit all of the pieces that you should. If you want to do the graphing calculator tutorial before you do these homework problems, that might be helpful to do.